Hi, chemistry students. So last week we looked at stoichiometry. We looked at mole to mole ratio questions. We did a little bit of practice with that. You may want to rewatch that video before diving in here, but now we're going to look at a mass to moles problem. All right, so that's the whole point of this video, to see how a mass to moles problem works. Just something to remind you. Um, the stoichiometry, these balanced chemical reactions, they only work with moles, all right? Because a mole is a counting unit. We can't do it with masses because different elements weigh different things. So to convert from mass to moles, we use the molar mass, all right? And this is something you should remember. Um, the mass of 1 mole of a substance is called the molar mass, and the formula we get, we do mass divided by molar mass to get moles. So let's just think about 2 elements, bromine and oxygen, bro. All right, anyway, these 2 elements, 2 different elements, assume we had 100 grams of each. 100 grams of bromine, all right, how many moles would that be? Well, because on the periodic table, it's got that molar mass of 79.90, all right, we're going to divide by 79.90. We're going to get 1.25 moles of bromine if we have 100 grams of bromine. All right, so this is how we are going to convert from the mass in grams to moles. We're just going to divide by the molar mass. Now, what if we have 100 grams of oxygen? All right, well, 100 grams of oxygen, we're going to divide by 16. Right, that's the important part. Each individual element has its own molar mass, so that formula mass divided by molar mass, it's always changing because it's based on which element we're looking at. All right, so 100 grams divided by 16, we get 6.25 moles of oxygen. All right, and that should make sense. If we have 100 grams of each, we're going to need much more oxygen because it's lighter than the bromine. All right, and something to remember, that's for pure elements. What if we have a compound? Hydrochloric acid, HCl. Well, hydrogen has a molar mass of 1, we could round, and chlorine's going to be 35.5, and we'll add it up. We're going to get 36.5, right? We just add them up. If it was something like glucose, C6H12O6, you're going to take the mass of carbon, which is 12, you're going to multiply it by 6, because there's 6 of them in the formula, 72. You're going to take the mass of hydrogen, which is 1, you're going to multiply it by 12. All right, so you're going to get 12 for the mass of hydrogen. Oxygen, you're going to take the mass of 16. You're going to multiply it by 6. You're going to get 96. You're going to add that all up. You're going to get 180. All right, so we have seen molar mass before. This is nothing new. I know it is a little bit of a review, but it should come back to you quickly. As long as you have a periodic table out and a calculator out, you're going to crush these problems. Absolutely. All right, so now last week, we started looking at the stoichiometry. All right, so here we have a chemical reaction. All right, 3P4, P4 is red phosphorus, plus 10 KClO3. This is potassium chlorate. This is the stuff we use to make our smoke bombs. Really cool stuff. Yields 3P4O10. We know naming, that is tetraphosphorus decoxide, plus 10 KCl. And KCl is just potassium chloride. That's the stuff that burned pink when we did the flame test earlier in the year. So let's say we get this question. How much KCl can be made from 15 moles of P4 and excess KClO3? All right. So what they're saying is we have 15 moles of the P4 and we have as much KClO3 as needed. It's excess. All right. And we want to figure out how much KCl we're going to make. So this is the type of problem we saw in the previous video, type of thing we saw last week. All right, we're going to take our 15 moles of P4, that is our given. We're going to multiply by this mole ratio. All right, again, the mole ratio uses the coefficients from the balanced reaction, but it only works if you're using moles. You cannot use grams. So I put what I already have, my given, on the bottom. That's the P4, and its coefficient goes with it, 3P4. I want to find KCl, so I put 10 KCl up top. So now I'm doing 15 times 10 divided by 3. Again, you have your calculator out, no problem with this question. All right, you're going to get 50 moles of KCl. So this is the practice that we were working on last week. All right. We'll do one more practice. All right. We have a new reaction now. 2C8H18 plus 25O2 yields 18H2O plus 16CO2 plus energy. All right. This is octane plus oxygen yielding water plus carbon dioxide. Octane, as some of you will remember, is the main chemical in gasoline. All right. So I know for myself, I'm not driving to work much, so I'm not combusting as much octane as I used to. But this is the reaction that lets the school buses take us to school whenever we're able to go back. All right, so here's our question. If 3.9 moles of octane combust with excess oxygen, all right, as much oxygen as we need, how many moles of carbon dioxide are produced? All right, so we want to take our given information, the 3.9 moles of C8H18, that's octane, and we want to multiply it by a mole fraction. All right, so what we already have, our given, goes on the bottom, 2C8H18, and what we want to find, right, how many moles of carbon dioxide are produced, what we want to find is going to go on top, 16 CO2, right? So I want you to think, for every 2 C8H18, we need 16 CO2, or we get 16 CO2. All right, so 3.9 times 16 divided by 2, man, you're going to really want that calculator. 31.2 moles of carbon dioxide. All right, this is the easy version of the question. This is the mole to mole question. You are given moles and you find moles. Here's the hard question, guys. This is going to put it all together for this video. If 200 grams of octane combusts with excess oxygen, as much oxygen as we need, how many moles of carbon dioxide are produced? All right, so what you might be tempted to do is do the 200 grams of octane and then multiply it by 16 divided by 2, but that will not work. You cannot use that mole ratio unless you have moles. All right, we don't have moles. We have 200 grams of octane. But can we convert 200 grams of octane into moles? Yes, we can. We just saw it at the review at the very beginning of this video. So we take our 200 grams of octane, C8H18, and we divide it by its molar mass. Does anyone know the molar mass off the top of their head? I know I don't. So I'm going to look at my periodic table. All right. I have 8 carbons. The molar mass of carbon is 12. So I got to do 8 times 12. That gives me 96. I got to take hydrogen. There are 18 hydrogens. Hydrogen from the periodic table has a molar mass of 1. So now I'm doing 18 times 1. I get 18. 96 plus 18 gives me a molar mass of 114 for octane. Right? I just used the periodic table, those lower numbers. So now I'm doing 200 grams of octane divided by 114 grams per mole. That equals 1.75 moles of C8H18. All right, so this is a two-step problem. I got to convert my grams of the given into moles, but all I have to do that is divide by molar mass. Now I have 1.75 moles of C8H18, and I'm going to multiply that by the mole ratio. 16 carbon dioxides up top, 2 C8H18s on the bottom. All right, so now I can use the mole ratio because I have my moles. All right, so 1.75 moles of C8H18 times 16 divided by 2 gives me 14 moles of carbon dioxide. All right, so this is your example for a mass to mole question. It is 2 steps. You have to take the mass and divide it by the molar mass of that given element or compound to convert it into moles. And then you use the mole ratio, right? The coefficient of what you want from the reaction goes on top. The coefficient of what you have been given goes on the bottom of that mole ratio. All right, 2 steps. So we'll do a little bit of practice with it this week. All right, and then in our next video this week, we are going to see the last question I want to show you, which is a mass to mass question. All right, mole to mole is easy, 1 step. Mass to mole, 2 steps. Mass to mass, that's going to be 3 steps. All right, but we'll see that later on in the week. You don't have to worry about it for right now. All right. So that is it for mass to mole problems.